Well, I have some students asking me to explain this problem. So you have a battery, oops, 9 volts, V, right? V 9 volts, and is removed from the circuit and reinstalled with the polarities reverse. Uh, so when you put in a new circuit, the polarity is reversed. So now the plus is to the right, the negative is to the left. So, but originally that's what you have. So what I did, I changed the resistance given from 9.1 to 5 just to show you one thing here. So let's say you look at the circuit and you say, hey, in the upper branch I have a 3 plus 2, 5 ohms, right? They are in series because the current that flows in this upper branch is the same. And then you say, hey, I can simplify those two and put a 5 ohms resistor in there. Yes, you can. Same thing here. You go from uh, this junction and flows to the other junction, 4 plus 1, 5 ohms. Yes, cool. And yes, my professor is very nice. Put another 5 ohm resistor in the lower branch. So 5 ohm, 5 ohm, 5 ohm, they are in parallel. Guess what? They are not. Why is that? Well, the dropping voltage across the resistors terminals. So this guy, the equivalent here in the middle branch, the equivalent in the upper branch, the dropping voltage is not the same. Because of that, these resistors are not in parallel. So you cannot simplify. You gotta face your Kirchhoff rules. So how do you do that? So first of all, the first thing you do when you have a circuit like that is to establish directions for your currents. That's what I did up here. See that? So I put my I1 current, which leaves this point, go all the way to the upper branch, circles around, and then dies in this junction. I2 leaves this junction and then goes through this middle branch, pass through this 5 volts battery, and then dies out in there. So if the upper current is I1, the middle current is I2, the two meet in this point, and then they comes together as I1 plus I2, like a water that flows in two independent pipes and then they merge in a T junction and they add up to a final uh, water flow in a thicker pipe. And then they go as I1 plus I2 down here. So once you have established the directions of your currents, what you go through your pluses and minuses. So how do we do that? Well, for the power supply, not a big deal. You just put plus and minus plus all this in the bigger or positive polarity of your power supply. For the current is a little bit tricky. The only thing you need to remember is that current flows from the positive to the negative terminal of your resistor. Or if you think about water, water runs from high potential to low potential, right? So if you have water in a box on the roof of your house, the water will flows down. But if you have water in the well in your house, you need to put some energy to move and to suck out water up to your house. So high potential to low potential. So in this case of your current, that means if you were to give pluses and minuses, the current flows from the positive to the negative, positive to the negative, positive to the negative, positive to the negative on the 4. And in this case, it's different, right? It goes counterclockwise. So it goes from this terminal to this terminal. So once you've done that, what happened? Well, you take your 9 volts battery and then you reinstall in the circuit. Now you have your 9 volts better. You kind of reverse that way. Okay, but you have your definitions already set. The only change you need to do is that now your positive polarity is closer to point A. See that? Because you reversed. You reverse. You took it out and you reverse. Okay. But you don't want to make too much changes, so you assume, okay, the currents will be in the same direction. So you keep the currents in the same direction, right? And then the definitions or that you had established before are the same because the currents flow in the same direction, presumably. And then you go through define your loops. So call loop number one, loop number two, and then you do your Kirchhoff by starting a point. So let's take loop number one and start in point B, for instance. So you have your VB, right? You start in this point, and then you go to the right. So VB, and then you have a gain in potential. Gain in potential. You go from low to high potential. Again, you put a positive sign. Plus 4I2, which is the voltage drop across this terminal. 4 is the resistance. I2 is the current in that flow, in that branch. And then you go down, and then you go from low potential to high potential. Is a gain. It goes with a positive sign. 5 times the current that goes in there. I1 plus I2, you plug it in here. And then you go up the branch, take the junction, and then go right on it. So you go from low potential to high potential. You have a gain, 1 ohms times I2. And then you have a drop in the voltage here, which is negative 5 volts. And then you arrive at the letter B, equal VB. Don't forget that. Now VB cancels out. And then you're left with this nice equation. When you do the same steps in loop number 2, you start point A, and then you have a gain, pause 3I1, because I1 is the current in the upper branch, and then you go down to this junction and to the left through the resistor 4 ohms. But look at this, you go from positive to negative is a drop. Drop goes with the negative sign, 4 times the current that flows in there, I2. And then you have a gain in this power supply, plus 5. And then you have a drop, positive to negative. Positive to negative is a drop. Go with a negative sign. 1 ohms times the current I2. It's negative I2. And goes, I don't know where I go. Oh, I go up, right? Because I'm looping 2, go up. And then you go through a low to high end. So you have a gain plus 2 times the current in there, I1. And then you have another gain, which is plus V, which is 9 volts. And then you arrive at letter A, or point A, VA. VA cancels out. And then you're left with this nice equation. So you have your V, in fact, is 9 ohms. So this is minus 9 minus 5 is 9 minus 914. So then you have two equations, two unknowns. You should solve that for that, right? And then you can calculate your I1 and I2. And then sometimes when you do your Kirchhoff, your final currents, the currents you calculate, will be negative. So if they are negative, it means the original configuration or the original flow you had established or set, it's not the right one. So if you find any of these results negative, it means that the original flow that you had thought about it is not the right one. And then you will reverse if that is asked to do. Now, if you want to find VAB, I think that's one of the questions, isn't it? Let me see. Yeah. So you found your current, right? And then potential difference, VAB. So VAB. So you want to find VAB. You want to find VAB. So you to find VAB, you do the same thing we did before. You start VA, point VA, right? Um, and then you're gonna go. You want to go to point B. So you can go from A to B like this. You can go to A to B like that, right? To the left. Or you can do a very long trip if you like. If you are adventurers, you can go like this. Or you can go kind of a crazy. You can go like that. And then down. And then like that. That's a long route. I mean, the simplest one is if you start here and then go that way, right? So let's take our route from A to B like this, A to B. So then you pass only through two resistors. This is the simplest one. So you start with VA and then look at this. So forget about your loops, right? So you don't need the loops anymore. We use the loop to calculate currents. Now you want to go from point A, not to point A again, but from point A to point B. So you do the same stuff. You go VA, and now to go down through this right hand side of this branch, you have to pass through the 3 ohms resistor. So we have to go from low potential to high potential. So it's a gain plus 3 times the current in there, and that is I1. And now you get to this point, you have to go from high to low, which means you have a drop, negative 4 times I2, right? That's the current in there. And then you arrive at letter B equal VB. Okay. And then you can play around like VA minus VB is equal negative 3I1 plus 4I2 when you rearrange these terms. But what is VA minus VB? This is your VAB. This is what you want. Negative 3I1 plus 4I2. And then you can calculate how many volts that is, right? Once you had calculated before your I1 and I2. So that's how you do the problem. So if you have a problem, just let me know. Okay, cool.